Hello. All right. Good afternoon, everyone. My name is John Brock. I'm a product manager here at Salesforce, and I run platform events and change data capture. And up here with me,
I'm Yasaman Mohsen, and I'm engineering manager with CDC team.
so first off, thank you so much for coming out today. This is a really interesting session from my point of view. Really the first time we've presented this, so would love to get your feedback on the messaging, the feature itself, what your use cases are, because it really is the first time we're talking about this brand new concept of asynchronous Apex triggers and change data capture. So our forward-looking statement slide, everyone knows and loves this. Please only purchase based off of what's GA and available today, not some of the roadmap forward-looking statement slides we'll make in the next slides. So before we start, who has written an Apex trigger before? I hope everyone's hand is up, or you have a trailhead in progress where you're writing one. How about using change data capture? Uh-oh, not so great, only a couple. So the first couple slides, I'm gonna do a quick primer on what change data capture is so that you kind of understand what it is and how it powers these asynchronous Apex triggers. So Salesforce is a great operational portal for all of your data. But at Salesforce, we kind of, I'm gonna be honest with you here, lie to ourselves that you only keep your data in Salesforce. Right? The reality is you actually have data in all your other enterprise applications, and you need to get that data to those other systems in real time in a high fidelity, low latency type of way. You have this chasm though, the gap, if you will, of how do you get that data from Salesforce to your other applications, maybe AWS or SAP, in a real-time manner. That's why we introduced change data capture, and it went GA first part of this year in the spring 19 release. It is the best way, most reliable, robust way to capture data changes happening in Salesforce without any code. You don't have to write any Apex, you don't have to do any configuration. All you need to do is go to the user interface, select which object you want to capture changes on, and we do all of that heavy lifting. Yasaman's team does all the PL SQL code, all the Java code, all the low-level framework code to capture all these changes in real time, and then publish an event to the event bus so that downstream systems receive that event in real time and can take action on it. So again, no code to enable this. All you do is go to the UI, enable it, and you start capturing changes. The next thing is all these systems, when the event is on the bus, receive the event in real time. There's no delay, there's no artificial window of gap that you're waiting, there's no polling, no batch ETL. If you're subscribed to the stream, you receive that change event. And then additionally, because it's built on high volume platform events and the scalable architecture the other side of my engineering house works on, you can store up to 3 days of events. So if your downstream system goes down over the weekend for maintenance, you can restart it Monday morning and catch up all those events that happened over the weekend so that you can get a real-time view as soon as the business comes online on Monday. There's 3 major use cases that I talk with customers about every single day related to change data capture, and they're kind of siloed into these 3 main buckets. The first is data replication, and we've touched on this before. How do you make sure all your other systems have a real-time view of your Salesforce data in real time as it's changing? The second is process automation. How do you trigger downstream actions when a data change in Salesforce occurs? So what if when an opportunity changes to the closed status, I want to kick off order fulfillment processes? Well, I can do that with change data capture. Audit and compliance is the third main bucket. So some customers need a breadcrumb trail of every single change that happens in their Salesforce org, hydrating a data lake so that they can run machine learning or analytics or audit and compliance reports over. Basically a holistic view of their data from T0 all the way up to the point in time that they're querying that data lake, if you will. It also offers the capability where once you have your data in the data lake, you can join other data from other sources to that common lake, and you're keeping the Salesforce data up to sync in real time because the change events are delivered as they happen in the system. So now that's an intro to change data capture so you can understand how we capture the change, what it's doing, but how does that relate to Apex triggers? Well, they're very coupled. They're very, very much one and the same. change data capture is the framework behind asynchronous Apex triggers. So today, your Apex triggers, as you can see on the right-hand screen, you're writing a case trigger on the case object itself, right? Very simply, your case is being updated. Inside the transaction, you're doing other business processing. You're doing data validation. You're doing object manipulation on related objects or fields. You're doing different data integrity checks, if you will. You want to make sure that when that transaction commits, that the commit commits data in a good state. You don't want data to be committed in a poor state where you have to go back, redo it, clean it up, change it later. You want all that validation and those related objects to be updated in the same transaction as that parent update. And so Apex triggers are great for that. Additionally, users, the end user experience is very seamless, right? When an end user is using Salesforce and they update a Lightning detail page, they don't understand there's processes and flows and Apex triggers and all your customized business logic that all of us write every single day running behind the scenes. All they see is a standard Salesforce error that says, oops, I forgot to fill in this one field. But you made that determination. You made that code happen. The user gets that great experience because it's fast, it's right in their face. They can't move on until they fix that problem. And then they're able to commit that data in one manner or in one transaction. Additionally, it's highly coupled with the transaction, meaning if your data is committed, we guarantee you that the changes you did in the trigger or your process or your flow was committed in the same unit of work as that original data change itself. Conversely, if you roll back that transaction because of an error you throw, because of an error on the platform, all the actions happening in that one unit of work are also rolled back. So that's very beneficial. But what happens if you have actions or business logic that's not transactionally bound? You don't need that to be run inside the transaction. And that's why we're talking about async Apex triggers. So the idea here is move all your non-transactional logic outside of the transaction and put that in a trigger on the change event itself. So what we have here is a brand new feature in summer 19, which is Apex triggers on change data capture events. So you can see here, I've written a trigger on the case change event. As we talked about in the first slides, the change event is published after the transaction commits, after the data is updated. That event is published to the event bus. Once the event's on the bus, we deliver it to all the subscribers. Maybe those subscribers are external, off-platform, or maybe they're the Apex triggers that you define and you code up. So these are running asynchronously after the transaction, after that change event has been published. So in this way, you decouple that heavyweight processing outside of your transaction so the end user doesn't have to wait on a spinning arrow in their UI screen. You're not doing in-transactional holding DB threads for some computation that's not a dependent action of the transaction itself. And then additionally, because it's built on events, it's more decoupled, right? You can scale these. So imagine I had 4 different triggers on case change event that were performing independent actions. They're all decoupled through events, but they're also receiving events on external systems for those same case change events, if you will. So it's a very highly scalable, highly decoupled, event-driven way to create an async trigger on the platform with native capabilities that are now available to all of you as of summer 19. So when should you consider using an asynchronous Apex trigger, and when should you keep the Apex triggers that you have today? It's a great question because Apex triggers are great and they solve many use cases. They've been around 10 or 12 years, and they're really one of the secret sauces, I would say, of the Salesforce platform. And so keep in mind, they are perfect for data validation, data integrity, filling in required prerequisite operations, figuring out, updating related objects, doing all the things that need to be committed in one piece of work, one unit of work. But think about the things that you do in those triggers today that could be pulled out of the transaction. Are you trying to do an Einstein machine learning prediction? Are you trying to do an aggregated summary view across multiple different records, multiple different objects that's not related to the transaction that triggered that? You just needed a hook to put it in the process somewhere, right? Move that outside of the transaction. Move it outside so it doesn't hold that DB thread or that trigger thread, and have it execute asynchronously as resources are available. So we're going to bring up Yaseman, and she's going to show how Cody is using asynchronous Apex triggers to have a nice prediction process in the service shop.
Okay. Thanks, John.
Oops. Uh-oh.
So we're going to demo what John just introduced to us, async CDC Apex trigger. With CDC triggers, a new paradigm is introduced for Apex, completely async triggers. The heavy computation and resource-intensive tasks are removed out of that transaction. Therefore, it improves the transaction time and limit utilization. So transactional logic stays in the transaction, and the business logic is moved out. Cody runs a vehicle repair shop using Salesforce and different features in Salesforce to manage the customers and also the relationship with the parts supplier it has. Cody has enabled CDC event for account, case, couple of other standard entities, and an entity which is custom entity parts. By enabling CDC for these events, they will receive a CDC event every time a change happens for the records that they are part of these entities for a creation, update, deletion, and undelete. They can also write Apex triggers on these entities. Let's look at one of these Apex triggers. This is an Apex trigger that is written for case change event, which points to case and the changes that happens to a case. We're using after inserts similar to Apex triggers. We are going to go through the changes that we receive for cases and retrieve the ID of the cases, the record ID of the cases, and we're going to add those record ID to a list called case IDs. Then we're going to use these case IDs and call a heavy computing using ML and also Salesforce Einstein to predict the risk of each account based on the case that we have received. And this is done by calling the red account predictor. Once the red account predictor does the prediction, it returns to us a matrix of account and their status, red for being at risk and green for being okay. Then we're going to go through all these matrix that we received, and for those accounts that they are marked as red account, we're going to create a red account platform event. And we're going to add that to the list of platform events that we have for red accounts. Later on, we're going to publish these red account platform events. So what we just looked at was the async CDC Apex trigger. So let's look at the process builder we have. So as we were talking about, we saw that we had a platform events for a red account that we published. So this process is looking for the platform events red account, and it associates that with an account. It's always running, and it does two actions once we have that platform events. The first thing is to update the rating of that account, if it's from green to red or from red to green. And the second action will be posting to Chatter the previous rating of that account. So now let's look at this one in action. So we have an account called Astro, which is a customer of Cody. And as Cody is having his customer service representative pick up a phone, a new phone call comes in from Astro. So Astro is having problem with an autonomous feature of the car. It's saying it doesn't need the part immediately, so we'll leave the priority as medium, and we receive this one as a phone call. The part number he's having problem is PA400. PA400. Okay. And we're going to add a subject for this case. Oops. Astro needs help. Pardon my misspelling, it's not my own keyboard. So before I save this case, I would like to show you the supplier side. So the supplier is using a Heroku app to subscribe for the events that comes from the Cody's Salesforce org to see is there any change on the cases or accounts, and just to keep an eye on it and the priority of those cases. So he has subscribed to change events, which means that they will receive all the CDC events for the entities that we enabled earlier. So he's subscribing to that. We see that it's subscribed. And now we're going to save this case. OK. So we see that we got a UI pop-up saying the account is green. So this is great. So nothing is at risk. And let's go and look at the Astro account. So as you remember, there was also one of the part of the process was to post on Chatter. So the previous rating was red, and now it's green. And let's look at the detail, and it's a green account. So all is good. Let's look at the part supplier. So we see that they received a CDC event. It's a create on a case, and it has the information that we have put in for the case. It has the part number, and it has the priority of the case, which is medium. At this point, the part supplier says, OK, this is not the highest priority case that came in. I have higher ones, so I'm just going to just leave it there and then get to it later. On the Cody side, we just received another phone call from Astro. Astro was invited to TDX19 and needs to get to San Francisco, so he needs his car to be fixed. So we need to change the priority of this case to high. So the case priority change, boom, you see that we get a UI pop-up that the account is red right now. It means that it needs immediate attention. And here as well, we'll see that the rating has changed to red. And also on Chatter, a post was done, which is saying the previous rating was green and now we're red. Let's look at the supplier part. So we see they received also the CDC event for the case, and now they see the priority is high. So they say, OK, now we need to take an action. This is important, high priority case. So they will use this to send a platform event back to Cody Salesforce, saying that the part was sent to Astro, and it's on its way. Here, we'll see, once we receive that platform event, we say, oh, the account is back to green because they acknowledge that they've sent out the part to Cody. And again, if we look at here, we see this is green. And if we do a refresh, we'll see that a Chatter post was posted saying that the previous one was red, and then right now the new rating is green. So thanks to the end-to-end demo that we just saw, we saw that this CDC Apex trigger was listening to CDC events. And then it used Salesforce Einstein to do the heavy computation outside that trigger. And then they were able to, based on that results of the computation, to publish a platform events. And then we saw the Heroku app that it was listening to the CDC events, and it was also able to publish events back to Salesforce. And thanks to all the amazing features that we saw and the CDC, Astro was able to get to TDX19, enjoy it as much as you guys are doing, and I hope you're doing, and just using CDC events and platform events.
All right, thank you, Yaseman. That was great. And keep in mind, thank you, yes. You know, the interesting thing about that demo is really showing the power of platform events and the event-driven concepts coming to Salesforce Platform. They are highly coupled inside the platform, not only on Apex triggers, flows, process builder, but through all of our APIs. And you can really see how some of these pieces are now starting to come together so that you can create truly end-to-end decoupled event-driven flows, completely native on platform, completely clicks or code, and we're really appealing to all the different audiences with these new tools that we're trying to build. So with that, I do want to wrap up because we're coming down here on time. I'll flash the roadmap up here because I know this is a popular one to take a picture of. But I just want to thank you for coming out today. Really appreciate it. Enjoy your Trailhead DX. And I'll be presenting a session tomorrow on high volume platform events in a breakout room. So be sure to come and check out that one. Thank you very much.